cooling systems. This video will enable you to list and describe the function of the basic parts of a cooling system. It will discuss theory and compare cooling system design variations before explaining typical repair methods. You will learn to analyze common symptoms and their sources of trouble. You will see how to perform several cooling system tests before learning how to replace faulty components. A cooling system, as you will discover, is extremely important to the service life of an engine. The basic parts of a cooling system are illustrated in this graphic. The water pump is a source of pressure to move coolant through the system. It is normally operated by a belt running off the crankshaft pulley, but it can also be operated by a gear mechanism on the front end of the engine. The pump forces coolant through the radiator, up to the lower radiator hose, through the block, up through the cylinder head, past the thermostat, through the upper hose, and back into the radiator with most system designs. The flow of coolant through the engine collects excess heat. This heat is then carried by the coolant to the radiator for heat transfer into the surrounding air. Water jackets are the hollow areas in the head and block for coolant flow. They surround the hottest areas in the engine and protect them from overheating damage. Since temperatures can exceed 4,500 degrees, metal parts would quickly start to melt or crack without proper coolant circulation. Water jackets collect excess heat caused by combustion and transfer it into a water antifreeze solution. Antifreeze is very important to the proper functioning of a cooling system. It provides freeze-up protection in cold weather, better heat transfer than water. It also lubricates the water pump, and it prevents rust formation in the system much better than pure water. Ideally, a 50% mixture of antifreeze and water should be used. The water pump normally bolts to the front of an engine like this one, but in some cases, it can also bolt to the side of the engine. These locations allow the pump to efficiently force coolant into the block and head. Here's a modern water pump mounted on one side of the block. It is belt-driven and has large fittings for the water hoses. This cutaway shows the basic action inside a water pump. The engine belt turns a water pump pulley. The pulley then sends power into the pump. The spinning impeller can then pressurize the coolant, forcing it through the engine under pressure. The impeller uses centrifugal force to form pressure. The coolant enters near the center of the impeller. Then the spinning impeller blades throw the coolant outward by utilizing centrifugal force. The coolant is then directed to openings in the engine which lead to either the block with conventional coolant flow or to the heads with reverse flow cooling. The belt pulley bolts to the water pump hub. The hub then transfers turning force through the water pump shaft to the impeller. The hub is often press-fit on the water pump shaft. It has threaded holes to hold the pulley and sometimes the engine cooling fan. A seal is formed at the front of the water pump to prevent leakage. By removing the rear cover, you can view an actual water pump impeller. Note the shape of the blades, which are able to direct the coolant outward and through the passages into the engine. Gaskets seal the joint between the water pump and the engine. This side-mounted water pump has a unique drive arrangement. It is a splined shaft that meshes into the rear of the drive gear. The timing chain on the engine, not a rubber belt, powers this pump. Here you can see how a fan typically bolts to the front of the water pump. The pump shaft is made of hardened steel so that it can support moving parts without excessive wear. The water pump bearings support the shaft as it spins inside the pump housing. With large, longitudinally mounted engines, a metal fan is normally used in the front of the pump. Many fans use a thermostatically controlled clutch to control fan action. The clutch slips when the engine is cold to save energy and speed engine warm-up. When the engine and clutch warm, the fan clutch engages to force a huge amount of air through the radiator and over the engine. This cutaway shows the mechanism inside a fan clutch. Electric fans are also very common, especially with transverse or sideways mounted engines. An electric motor powers the fan to circulate air through the radiator whenever the engine is at operating temperature. This complete car cutaway demonstrates how, when a car is moving, outside airflow through the front grille helps force air through the radiator and the air conditioning system condenser, shown on the right of the radiator. The radiator consists of tanks soldered or bonded to a core. Metal tanks are soldered in place. Plastic tanks are bonded. The radiator core has a series of small metal tubes attached to cooling fins. The radiator neck and hose fittings may be formed on the radiator. Sometimes a heater hose fitting may be provided on one of the tanks. Small tube fittings often lead into an oil cooler mounted inside one of the radiator tanks. The oil cooler behind this tank removes heat from the automatic transmission fluid. The transmission's oil pump forces the fluid through the system for heat removal. This radiator uses lightweight plastic tanks. A cross-flow radiator has the coolant flowing sideways. The tanks are mounted on the right and left of the core. A downflow radiator has the coolant flowing from top to bottom. A pressure cap mounts on the radiator neck or on a reservoir tank. By pushing down and turning, you can remove or install the cap. One rubber seal on the radiator cap contacts the top of the radiator neck to allow overflow action. The smaller seal is a pressure seal. A vent valve allows the entry of coolant from the coolant reservoir. A large spring determines cooling system operating pressure. When warm and too full, excess coolant opens the cap pressure valve so coolant can return to the reservoir. During cool down, coolant contraction and the low pressure pull coolant into the radiator for automatic refilling. Large reinforced hoses connect the radiator with the engine. The bottom hose often goes to the water pump and the top hose to the thermostat housing. Smaller hoses connect the reservoir to the radiator and allow for a drain out onto the ground. The thermostat housing is an enclosure for the thermostat. It can also provide metal fittings for various hoses and threaded holes for sensors. The coolant temperature sensor can thread into the side of the thermostat housing. The thermostat and its housing are often located at the top of the cylinder head, like this one. However, the thermostat can also be mounted in the side of the cylinder block. The thermostat is the main control over the engine operating temperature. It uses a small pellet of wax that expands and contracts with coolant temperature changes. When parts are cool, the spring holds the seal or valve closed. This causes the water pump to circulate coolant through a bypass for quick engine warm-up. When the coolant warms to operating temperature, the wax pellet causes the thermostat to open and allows normal coolant flow through the system. With changes in temperature, the thermostat can open and close different amounts. Mentioned briefly, with a reverse flow cooling system, the water pump forces coolant through the head first, because the cylinder head surface temperatures can be higher than in the block. When inspecting a cooling system, be careful. Feel the radiator and hoses to make sure the system is cool enough before opening the cap. Make sure the coolant is not badly rusted or contaminated with transmission fluid. To check freeze-up protection, use an antifreeze tester. Draw coolant into the tester and check how many balls are floating. The more balls that float, the lower the outside temperature can go before the solution freezes and cracks the engine block or other parts. If not enough balls float for the coldest possible temperature, add antifreeze to match the climate of the area. Ideally, a 50-50 mix of antifreeze to water is recommended. A handy trick for checking the age and condition of the antifreeze solution is to use a voltmeter. Stick one probe into the coolant and ground the other probe. Then read your meter. If your voltmeter reads over 0.4 volts, it is time to replace the coolant. A high voltage reading shows that the coolant is very acidic and will corrode internal components. To drain the coolant, open the petcock on the bottom of the radiator. Then add the correct mixture of antifreeze to water to restore the cooling system solution. A mixture chart on the back of the antifreeze container often gives information on how much antifreeze should be used depending on the capacity of the car's cooling system. Compare cooling system capacity on the left with the coldest possible temperature to find the number of quarts to add to the system. A bleed valve is sometimes provided near the top of the engine to help remove air when filling the system. If a bleed valve is not provided, crack open the top radiator hose to help purge the air when filling. A pressure tester is commonly used to check the system for leaks. It will check the radiator, hoses, freeze plugs, and other components for ruptures. Remove the radiator cap and install the special tester cap over the filler neck. Push down hard while turning. Pump the tester handle until the pressure gauge reading equals the system pressure rating. If you have the correct cap, read the numbers stamped on the top of the radiator cap. Don't go beyond pressure specs or you could damage the radiator and other components. With the system pressurized to specifications, or about 15 pounds per square inch, check for leaks. Look around the radiator, gaskets, water pump, freeze plugs, and hoses. Your repair may simply involve tightening a loose hose clamp, or it may involve time-consuming engine removal to get at hidden freeze plugs that have rusted through. Bleed pressure by twisting on the lever on the top of the tester cap. This will keep coolant from blowing out into the shop area. With a tester handy, you should also use it to check the condition of the radiator cap. Mount the adapter onto the tester, then fit the old radiator cap onto the adapter. Make sure you have a tight fit at the adapter so you can get an accurate test of cap condition. Pump the tester handle while watching the pressure gauge. The pressure should steadily increase until the cap spec pressure is reached. Then the cap should release pressure above its spec. The radiator cap should also be able to hold this pressure without leaking. Replace the cap if it fails these tests. This cap is leaking and must be replaced. To service a radiator, remove the top and bottom radiator hoses. Loosen the clamps and then pull while twisting on the hoses. Unbolt the cover or bracket that holds the radiator down into the vehicle, then unbolt the radiator shroud, which may be formed as part of the electric cooling fan mount. If the shroud is cracked or broken, repair or replace it. Without a fan shroud, the engine can overheat because air will bypass around the radiator. Pull the shroud or electric fan back and away from the radiator. If needed, Use a tubing wrench to unscrew and remove any oil cooler lines. This will let you lift the radiator out for service or to send it to a radiator shop. Fan service begins with a visual inspection. Make sure that the fan is not loose and that the clutch engages and starts blowing air when the engine warms to operating temperature. For safety, inspect the fan blades for signs of cracking. Mechanics have been killed when a cracked fan blade flew off and hit them with deadly force. Replace the fan if any signs of damage or cracks are located. If an electric fan fails to turn on when the engine warms, use jumper wires or this starter switch to jump battery voltage directly to the fan motor. If the fan motor begins to operate, you know to test other parts of the fan circuit. You may have a bad fan relay, a bad coolant sensor, or a bad electrical connection in the wiring. Usually the coolant sensor energizes the fan relay, then the fan relay can carry the higher current to operate the fan motor. Use a wiring diagram for the exact make and model of car to analyze why an electric fan circuit is not functioning normally. For example, to test the coolant temperature sensor or fan switch, measure its temperature with a digital pyrometer while also checking its internal resistance with an ohm meter. If the resistance of the sensor is not within spec for the exact temperature, you would know to replace the sensor. Refer to service manual values for exact resistance and temperature specifications. Touch your digital pyrometer onto the metal part of the sensor when testing. If you found the fan motor to be bad, simply replace it. Parts are not available for motor rebuilding. Remove the fan motor bracket and install the new motor onto the bracket, then bolt the bracket and motor assembly into place on the vehicle. To quickly check the operating temperature of an engine, use a digital pyrometer. Touch the probe on the thermostat housing right next to the thermostat, then read your digital pyrometer. If engine operating temperature is too low or too high, you have found a problem with a thermostat, radiator, fan clutch, or other part. To remove a thermostat, first disconnect any hoses going to the thermostat housing. Remove any overflow hose and the large upper radiator hose. Unscrew and open up the hose clamp. You may have to pry carefully with a screwdriver to help free the hose if stuck to the thermostat housing. Then use a ratchet to spin out the two bolts that hold the thermostat housing onto the engine. Lift off the housing to gain access to the thermostat. Instead of hot plate testing of the thermostat, most mechanics simply install a new thermostat when the old one is in doubt. Clean off all old gasket material from the sealing surfaces on the engine and on the housing. You can use a gasket scraper or a special scuff pad mounted on an air tool. When scraping, do not gouge or nick gasket surfaces. The air tool is obviously much faster and will save time compared to a gasket scraper. The scuff pad will remove old gasket material, but it will not remove and damage the metal. Make sure you have the correct replacement thermostat. Check engine specs to determine the correct operating temperature you need. Do not rely on the old thermostat temperature rating. Someone could have changed the thermostat and installed the wrong heat range. If you don't check specs, the new thermostat could cause the same overheating or overcooling problems you're trying to fix. To avoid damage, make sure the thermostat fits down into its recess formed in the engine or on the thermostat housing. Wipe gasket sealer on the housing to hold the gasket in place during assembly. Wipe a thin coat all the way around the gasket surface. After allowing the sealer to tack up, fit the gasket into place. The sealer should hold the gasket onto the housing or engine securely so that the holes line up. Assemble the parts, and then tighten the bolts down a little bit at a time. A common mistake is to over-tighten the thermostat housing bolts. This will warp or crack off the ears of the housing. Just snug them down. Then install the hoses back onto the housing. Make sure the clamps are positioned properly over the fittings and tighten down the screws securely. You may want to pressure test the system after repairs. To check for water pump noise, you can use a handy tool like this electronic stethoscope. Clamp the sound probe onto the water pump, then start the engine. The noise detector will amplify any bearing noise coming out of the water pump. Move the probe around to isolate the noise. Here's a badly worn water pump. It made a tremendous grinding noise with the engine running. The impeller was actually rubbing on the rear of the housing. A bad water pump will also show up when coolant leaks out of this drain hole on the bottom of a pump housing. If coolant leaks out the vent or drain, the water pump is bad and must be replaced. To replace a water pump, remove any hoses going to the pump, like this bypass hose. Remove any fan belts that go to the water pump or that block access to the pump bolts. Depending upon the design and location of the water pump, you will have to remove various parts in front of or bolted to the pump housing. Refer to a service manual if needed. If available, always use an air ratchet when working on a water pump. It will fit down into the tight quarters next to the pump. Unbolt the pulley and bolts that secure the pump housing to the engine. When removing the bolts, note the location of any special bolts or bolts with odd lengths. They must be reinstalled in their original locations. Without damaging sealing surfaces, pry off the old pump. The gasket will usually stick the pump to the engine. Obtain the correct replacement pump and compare it to the old one. Then use a scraper or air tool to clean off old gasket material. Remember that if you miss one chunk of old gasket, the new gasket can leak. You would have to redo the whole job free of charge. Make sure every piece of old gasket material is removed. Bond the new gasket into place on the pump or the engine, checking that all holes and passages align. While checking bolt lengths, install the new or rebuilt pump in reverse order of removal. Fit the pump into place without disturbing its gasket. If you bump the gasket, check its condition and alignment before proceeding. Tighten the bolts in a crisscross pattern to compress the gasket evenly and prevent damage or leakage. Finally, fill and pressure test the system.